Ahí está.
5, 4, 3, 2. Good morning, students. Welcome to the Energy and Transformation class. Today is Wednesday. As you can see, I'm not here, but, well, in a physical form, but I will give you the class of parabolic motion. Okay? As you remember, we were checking the movement in the x-axis in last week, right? After that, we started with free fall motion in the y-axis. After that, we started with the horizontal motion, but the horizontal motion, if you remember, was moving starting from the horizontal and then falling. Today, we will start with the parabolic motion, and the only difference that we have from the horizontal motion to the parabolic motion one is that in this one we will have an angle at the beginning and at the end. So, parabolic motion, as I told you before, is the motion through the air without a propulsion. Some of the examples that we can see this is in sports, okay, also in technology, and some of the engineering applications that we can use. In other words, parabolic motion is the motion of objects projected at an angle, as I told you before. And this is a graphic that I'm going to show you so you can see what is the movement of any object that you throw at an angle at the beginning. So as you can see, here we have an angle in a different way of the problems that we were solving before, that is only about the y-axis or the x-axis. In this kind of problems, we will be solving troubles that are in the x-axis because it's moving on the horizontal plane, and in the y-axis that is moving in the vertical plane. Okay, so the combination of these two will be with the exactly same equations. Okay, with exactly same equations, but now we will combine them. How? Well, in this way. And I'm going to show you what are some of the concepts that we will be using here. One of them is that the motion is accelerated. And when I say accelerated, is, as I told you in class, due to gravity. The acceleration due to gravity. And that is minus 9.8 meters per square second, as I told you in class. The acceleration is constant, okay, and downward. Talking about the y-axis. So, as you can see, each time you are moving up, the gravity is trying to pull the object down in a constant way. With one number, minus 9.8. Constant, negative, right? Talking about the horizontal axis, or the movement that we have in the x-axis, we have that the horizontal component of velocity is constant. And if you remember one of the classes that we were talking about velocity, when you have constant velocity, means that you don't have change in velocity. And that means that if you don't have change in velocity, the acceleration is, yes, 0. Perfect, okay? 0 acceleration because you don't have change in velocity. And if you remember acceleration, the definition is acceleration is the change of velocity on time. No change in velocity, no acceleration. And this will be something very useful for you to solve some of the problems, okay? So the other variable about the horizontal is that the horizontal and the vertical motions, both of them will use exactly the same time. So we will have the time that we calculate in one of the axes, in the vertical analysis, will be used in the horizontal analysis. And we will have two types of analysis here. Okay? Perfect. Now, these are some of the angles that you can use when you start with a parabolic motion. And as you can see, when you use the 45 degrees, is when you have the greatest distance on x. Okay? This could be something useful for you when you build your catapult for the science fair. Now, as I told you before, this is a parabolic motion problem. In a parabolic motion problem, you know that the maximum height, well, I'm going to show you another one. Okay, that in the maximum height, as I told you in class, you don't have velocity on y. So that is a variable that you can use in some of the problems that you will be solving. Okay, and that the vertical will be decreasing, the vertical velocity will be decreasing each time it's moving up until you get to 0, and then it's decreasing, or if you want to say it in another way, is increasing in the negative. Each time you move down, you will have a greater value in the negative way. Okay? Perfect. Now, to finish with the explanation and start with the problems, in conclusion, we know that projectile motion is the motion with a constant horizontal velocity. That means zero acceleration, because there's no change in velocity, and constant acceleration in y, because the gravity, or the acceleration due to gravity, will be exactly the same, minus 9.8 meters per square second. Perfect. Okay. Now, I'm going to show you, or I'm going to solve two problems. I chose the two most difficult ones. Okay. So if you know how to do these ones, you will be able to solve the rest of the two classworks. Okay. So I'm going to start with classwork 16. So classwork 16 is this one. Okay. So the problem is problem 3. Okay. Problem 3. I'm gonna zoom it so you can see it better. Let me check. Like that, I think that is better. Okay. Okay, this is problem 3, classwork 16. I think that this is one of the most difficult ones in this classwork. That's why this is the one that I am going to explain. If you can solve this, I think that the rest of the problems will be easy for you. Okay? So let's check. I am going to read the problem. An arrow falling a distance of 2,682 meters, reaching a maximum height. Okay, let's start drawing so you can understand this better. It says that you have a parabolic motion. You know that we are working in parabolic motion, right? And it says that an arrow falling a distance of 2,682 meters in x, that will be your x, reaching a maximum height, okay, maximum height of 610 meters, that will be here in this point, maximum height of 610 meters. Okay, then it says if the elevation angle is 42, okay, this angle 42 degrees. Calculate the initial velocity, and 2, the duration of the journey, and 3, the speed at which the arrow reaches the ground. Okay? So let's solve it. Let's check. The first thing to do in these kind of problems is knowing that you have two analyses, the vertical and the horizontal. I would like to start with the horizontal analysis here. Okay, and in the other side the vertical analysis. Okay, I'm gonna write it a little bit higher so you can see it better. Vertical analysis and horizontal. Something important that you need to know, and this is part of the explanation that I will give you today, is that in the two of them we use the three kinematic equations, the ones that we have been working all these weeks. And these ones are like this. Final velocity, well, I'm going to write it on x equals initial velocity plus acceleration time. Then the distance is equal to the initial velocity on x times the time plus a half of the acceleration on x times the square time, and final velocity equals initial, both of them are squared, and x plus 2 times the acceleration times x. Okay? In the other side we will have exactly the same equations. Okay? And I'm going to write it fast here because you know them, but now with y. Okay? So it's final velocity, y, equals initial plus acceleration time. This is y, okay, equals initial velocity on y times time plus a half of the acceleration on times the square time, and final velocity on y. Final velocity on y equals initial, both of them squared, plus 2 times acceleration times y. Okay. So, as you can see, they are exactly the same equation, but these ones are y and these ones are x. Okay? Something important and that will be very good for you to solve these kind of problems is that in the horizontal plane, you know that the distance or the velocity that you use when you throw an object like this will be always the same. The velocity in the horizontal plane is always the same. If you measure the velocity in the x-axis here, or here, or here, or here, it will be always the same. Constant velocity. That means zero acceleration. So the acceleration on x will be always 0. This is good for you because if the acceleration on x is 0, this is 0, this acceleration here is 0, and this acceleration over here will be also 0. Okay? So now I can eliminate them. Okay? So now we don't have this anymore, we don't have this anymore, and we don't have this anymore. And as you can see, if the acceleration is 0, this is something obvious, that the final velocity equals the initial velocity. They are constant. The final velocity squared equals the initial velocity squared. That is obvious. So we can erase it. And the only equation we will be using is x equals VOX times time. The other equation we will be using is that the VO x, okay, if you remember about the first classes that I told you that you can get the components from the magnitude, the VOX, that is the component in the horizontal axis, it's the magnitude VO cos of the angle. And on this side, the magnitude VO is the magnitude sine of the angle. Okay? Those are the only equations we need to solve the problem. Okay? And as you can see, it's moving from the three kinematic equations that we had, like, and that we have been using like 2 weeks ago. Perfect. Okay, I'm gonna solve this one. Okay. With this, I think that you're gonna be able to solve the rest of the problems. This is a difficult one. Okay. But if you have any questions, you can ask me by mail. So let's start. We will start exactly in the same way as we were studying in the last problems, and that is first the values I have. But this time we will analyze all the values or the variables that are in the x-axis on this side and the variables that are on the y-axis on that side. Okay? And that will be easier for you to solve. So 2682 is a value on the x-axis, and we know that the name of that one is x. So x equals 2682 meters. And that's the only value I have. Do I have VOX? Well, I don't have it. Do I have time? I don't have it. So we finished with the horizontal analysis. Now we will check what variables do we have in the vertical analysis. In the vertical analysis, you know that the maximum height, that will be y, I can call it max, y max, that it will be the maximum y. It's 610 meters. Okay, then another value we know is that the acceleration due to gravity, the AY, is minus 9.8 meters per square second. Okay? And the last variable we know, and maybe this is the difficult one, is that you know what the velocity is in the maximum height. In the maximum height, the velocity is always 0. So this is that the final velocity on y, when we are here in this point in the maximum y, is 0. That's what we know right now. Okay? So with these three values, you will be able to use one of the three kinematic equations to solve it. What do we want? Well, the first question is the initial velocity, right? But we cannot get the initial velocity right now. I will tell you how in a minute. The duration of the journey, okay? Duration of the journey, the time. To get the time, I need the VOY. So the first thing to get is the VOY. VOY, if I have the y, I have the AY, and I have the VFY, I can get it from the third kinematic equation. And this will be, if you isolate the VOY from here, that will be VFY squared minus 2 times the acceleration in y times y. So when we solve this, the VOY, I'm going to try to go fast in this. Okay, I have already calculated those values. So the values here will be, the VOY will give you 109.34 meters per second. This is my VOY. Okay, perfect. Now I want the time, because that's the second question. Okay, the time. To get the time now, I can use the first kinematic equation, because now I know the VOY, I know the VFY, and I know the acceleration. So the time, if I isolate it from the first kinematic equation, will be final minus initial divided by acceleration. And this will be final 0 minus initial. The initial is the one that we calculated here, divided by the acceleration due to gravity, minus 9.8. So the time will be 11.16 seconds. Okay? Now, check here, and this is very important. The time that you have here is the time when you have 0 velocity, okay, in the final, and when you have this initial. The important thing here is this. If you are using your final velocity as 0, that means that you are located here, because that's the only place in which you have final velocity 0, the maximum point. So if you are using this as a 0, that means that your time is here. And the time here is exactly the half of your travel. Do you want to know what's the complete time? Well, if you want to know that, multiply this by 2. Okay, so if you want to know what the total time is, the total time, okay, will be when you multiply this by 2. And that will be 22.31 seconds. This is the total time from here to here, the total parabola, right? 22.31. Okay, with this time, now, and if you remember, I told you that the time is exactly the same in the vertical analysis than in the one that we have in the horizontal analysis. So the total time used here is the total time. Why? Because it's the time from here to here. And we know the value of x from here to here. That value is this value, 2000, right? So if you know the time, total time, 22.31 seconds, and you know the x, can you calculate VOX? Well, you only isolate it. And that will be VOX equals x divided by the total time. That will be 2,682, 82 divided by the total time, 22.31 seconds. And that will give you the VOX. Okay? The VOX will be VOX 120.22. 120.22 meters per second. Okay? Perfect. So, right now we know the duration of the journey, that is 22.31. We know, well, we want to know the initial velocity, but check this, and this is important. When I say the initial velocity, only like that, initial velocity, I am not saying initial velocity on x or initial velocity on y. I say initial velocity. That is the vector. And the vector is magnitude and direction. Okay? How can you calculate that? Well, I'm going to try to do it here. Okay? You calculate it this way. And that will be, if you remember, the Pythagorean theorem tells you that if you want to know what your vector is, in this case my vector is the VO, the initial velocity, you need the two components. And in this case my two components, x, y, is the VOX squared plus the other component, the vertical one, that is the VOY squared. So if you have the horizontal component x and the horizontal component y, you can calculate the vector. Okay? So we have VOX, we replace it here. We have VOY, you replace it here. So my VO, my initial velocity vector, will be 163.41. 163.41 meters per second. I have the answer for the first one. Okay? Initial velocity, first question, 163.41, comma, 42 degrees. Magnitude, direction. Okay? First answer. The duration of the journey, 22.31. And the speed at which the arrow reaches the ground, I'm talking about this vector. Okay? Well, guess what? This vector, if it's on the same plane or in the same height of this one, will be exactly the same, okay, but moving in a different plane. So here this velocity will be the answer for C, the final velocity, the vector, okay, will be 163.41 meters per second. How do I know? Well, because remember that this is the half. So if you started with 163, in the other half is like a mirror. So you are getting with 163. And the angle, of course, is 42. The same angle that I used to start my parabolic motion. Okay? In this case, I have 41.98, that is an approximate value, and 162.94, an approximate value of 163. Okay? In the next classes, I will explain how to get this, but it's very easy. Okay? Right now, and because of the time, I will let it like that. The logic tells you that if this is like a mirror, if you started with 163, you ended with 163. The angle 42, because they are exactly on the same y and the same height. Okay? Okay? So that will be the problem, the explanation for you. And I think that with this, you will be able to solve almost all of the problems. If you want to see the problem, the complete problem, so you can copy it or check it later. With this, you will be able to solve classwork 16 and classwork 17. That is what I want you to do this Wednesday and on the next class, the last class of the week. Next class, you will have a quiz. This quiz is about acceleration and free fall. Okay? So it's acceleration with the three kinematic equations, okay, in the x-axis, and free fall with the three kinematic equations in the y-axis. So quiz, last class, on the last class of this week. Okay? Of course, I won't be there, but someone is going to apply the quiz for you. Okay? So if you want to repeat this video, you can check the link on Blackboard. You will find the link there in classes or in presentations. You will find the link. So you can repeat the video again and again if you want to check any of the explanations or any of the, the information that I gave you here. Okay? So have a nice week. I hope I see you later on Monday, because on Monday we will use some tennis balls so we can prove this information in a real problem. Okay, we will go outside on Monday, so I hope to see you there in class. Have a nice weekend, a nice week, and luck with this. If you have any question, as I told you before, send me an email so I can help you with that. Okay, you can take a picture if you don't understand something, and I check it, and I send an email back answering that question. Thank you very much for your attention, and see you on Monday.